Okay, thank you for having me here today. So I'm Rada Wu from Thermalytica. So I started this company about 3 years ago, and we provide advanced insulation materials. So we know that without any doubt that we know that we are entering the era of global boiling. So it's the end of global warming, and we are actually seeing much more extreme climate. So we believe that tackling global warming or global boiling actually requires two different approaches. The first one is actually making transition to renewable energy. Everybody knows about this. The other one is more rapid solution about implementing energy-saving technology. So this is the second one that we are focusing on. So there's an article a few months ago from CNBC saying that a shift to renewable energy is hopeless without efficiency, and because 75% of the total energy goes to waste. So we need to recover those energy. It's important. So where's the key problem? The key to solving this problem is actually insulation materials. And this picture shows the traditional insulation materials. They are very bulky and thick, and also they are not fire resistant. So we come out with a new material. So I've been trying to develop new materials for 20 years, and 3 years ago, we started this company called Thermalytica, and we make materials called tesa. So as you can see here, I have a video demonstration. Now with only 2 millimeters thick of tesa, it can create a temperature difference more than 1,000 centigrade, because this torch has a flame temperature of 1,300 degrees C. And also in terms of the economics, compared to aerogel, because many people know about aerogel, compared to aerogel, this material has 1/10 of the density. So theoretically, it's 10 times, up to 10 times cheaper in terms of the volumetric price. And this is the competitive landscape. So on the left-hand side, we have the conventional material. Sorry about that. I think it's not, the format is slightly changed. But on the right-hand side, we have aerogel, which has a good insulation, but the performance is good, but the price is too expensive to be widely adapted. So we come out with a well-balanced material called tesa. And also the market size for the green energy market is expected to be 23 trillion. And we are actually targeting the 4.4 trillion decarbonization market. It's a very important market, as you can see. It's almost comparable to the semiconductor and biotechnology markets. And also regarding the applications, of course, we are making insulation material so it can be applied to a wide temperature range. And I'm going to show today regarding a few examples. The first one is actually insulation pan for buildings. So here you can see that conventional insulation pan is based on the mechanism of reflecting solar radiation. But we have a different approach. We are actually creating temperature difference. So here on the left-hand side, you see that we have the best insulation pan on the market right now. So we benchmark our insulation pan against commercially available products, and we have the number one when we include 2% of our tesa powder into the pan. And also we have carried out a POC. POC is actually based on the buildings, and we calculate the actual energy saving. And with 2% tesa and a thickness of 0.5 millimeter, we can save 15% energy for these two testing buildings. And of course, similar to Japan, South Korea also has its own hydrogen strategy, and the key idea is to import hydrogen from Australia. So during importing, we have the long-distance transportation and the long-duration storage. And for this, we need to have insulation material which can be worked at a very low temperature. So we also have these solutions. And finally, the last solution is actually thermal runaway mitigation. And it is about inserting our thin film tesa sheets into the materials and also creating a temperature difference. So here you can see that I have actually testing this with a fire, and it's actually going well. So again, this is my final slide. Just quite quickly, this is a potential temperature applications with a different temperature range. Thank you very much.
Okay, thank you for presentation, Mr. Wu. Okay.